Suppose I have taken the example fx equal to sin x plus cos x. Now you see, you have to prove that the function fx is a continuous function. How can you prove this? See, solution. It is known that, what do you know? It is known that if g and h are two continuous function, then g plus h is also continuous. It is known that if g and h are two continuous function, then g plus h is also continuous. Means this is algebra of continuity. Okay, g is continuous and h is continuous, then g plus h is also continuous, then you can say the function is continuous. The function fx is continuous. Okay, so it has to be proved that gx equal sin x and hx equal cos x are continuous function. I have taken gx equal sin x, the first one, and hx equal cos x, the second one. Okay, let gx equal sin x. It is evident that gx equal sin x is defined for every real number. What I have written? It is evident that gx equal sin x is defined for every real number. I have not told you continuous. Okay, I have told you defined. It can be defined, but it may not be continuous. Okay, and sometimes it is defined and it can be continuous also. Okay, so next, let c be a real number. Let c be a real number. Put x equal c plus h. You can put x equal c plus h, or you can put c minus h also. Okay, means this is the right hand side of the point c, this is left hand side of the point c. Anyone you can put. Okay, so I have taken x equal c plus h here. If x tends to c, then h tends to 0. Means if the value of x equals c, then c get cancelled, so h is 0. So if x tends to c, then h tends to 0. Now gc equal, because the function is gx equal sin x, so if I replace x by c, then I will get sin of c. Therefore limit x tends to c, gx equal limit x tends to c. What is the value of gx? What is the function gx? The function gx is sin x, so I will put here sin x. Okay, next, equal limit. Now you see, if this is x, this is x, so when x tends to c, h tends to 0. So I will replace this x tends to c by h tends to 0. So if this is x, this is x, so if this is h, this must be a function of h. Okay, so I will replace x by x equals c plus h. So sin of c plus h equal limit h tends to 0. So break it, you can break this, sin of a plus b, this is the formula, sin of c, sin c cos h plus cos of c sin of h. Okay, equal limit h tends to 0. You can separate these two terms, sin c cos h plus limit h tends to 0 cos c sin h. So now put the limit. So if you put cos h equals cos, if you put h equals 0, then cos 0 is 1. So you will get here sin c, because sin c will be constant here. Okay, plus if you put h equals 0, sin 0 is 0. So you will get here 0. So this is equals to sin of c. Okay, and what is sin of c? Equal to gc. So this is equal to gc. So this is the definition of, you can see this is the definition of continuity. Limit of gx when x tends to c is equals to gc. Okay, therefore g is continuous. Therefore g is a continuous function. Okay, see again I am seeing you. I paused it. Okay, that is why it is not coming. See, similarly again similar to sin x, you have done let hx equal to cos x. It is evident that hx equal to cos x is defined for every real number. Let c be a real number. Put x equals c plus h. If x tends to c, then h tends to 0. Now h of c equal cos of c. Replace x by c, so you will get cos of c. Therefore limit x tends to c, h of x is equals to limit x tends to c cos of x, limit h tends to 0 cos of c plus h. Replace x by c plus h, because when this is x, this is x, and when this is h, this must be in terms of h only. Okay, so what is the formula? Cos a plus b, cos a cos b minus sin a sin b. So separate these two terms. Limit h tends to 0 cos of c cos of h minus limit h tends to 0 sin of c sin of h. Okay, so put the limit. So cos of 0 is equals to 0, cos of 0 is equals to 1. So here cos c is constant, so cos c into 1 equal cos c, minus, see here put h equal 0, so sin 0 is 0. So we are getting here cos of c only. So equal, what is cos c again? Cos c equal h of c. Okay, so you will get h of c. Therefore h is a continuous function. Hence it can be concluded that fx equal gx plus hx. I have taken gx equal sin x and hx equal cos x. Okay, is a continuous function. So this is the proof for it. Okay, let us take another question. So that the function gx equal x minus greatest integral value of x is discontinuous at all integral points. Okay, so that the function gx equal x minus greatest integral of x is discontinuous at all integral points. So how you can solve this solution? The given function. What is the given function? The given function is gx equal x minus greatest integral of x. Okay, so similarly we will write, it is evident that g is defined at all integral points. The function g is defined always. Okay, it may be continuous, it may not be continuous, but it is always defined. It is evident that g is defined at all integral points. Let n be an integer. Integer. Okay, so why I have taken n as integer? Because you see, this can be negative and positive also. Okay. Now, then Gn equal, what is gx? The function gx equal x minus greatest integral value of x. So what is Gn? It is n minus greatest integral of n. So what is greatest integral of n? This is n only. Okay, because this implies, what does this imply? If it was x, okay, x implies greatest integer less than or equal to x. So greatest integer of n, greatest integral value of n, it can be n only. It can be less also, but we have not taken less because this is n, this can be n. If this is 1, you can take 1, 2, you can take as 2. Okay. So n minus n, you are getting 0. So next, the left hand limit of f, not f, g. The function is g. Okay. Sorry. At g of g at x equal n is left hand limit. What is the left hand limit? Limit x tends to n negative gx is equals to limit x tends to n negative. What is gx? Function gx equal x minus greatest integral of x. Okay. Now you can separate these two terms also. You can write it as x tends to n negative x minus limit x tends to n negative greatest integral of n is equals to, this is n minus greatest integral of x. When x tends to n negative means smaller one. Okay, n negative means, here you can see, if this is n negative means n minus 1, n positive means n plus 1. Okay. So you see, n negative means the left hand side of the point n. All points to the left hand side of the point n. And when it is n positive, all points to the right hand side of the point n. Okay. So this can be n minus 1 only. Smaller one. Okay. Because this is n negative, so this can be n minus 1 only. Okay. This cannot be n. Is equals to n minus n. You are getting 0, n minus minus plus 1. Okay. Similarly, the right hand limit of g at x equal n is limit x tends to n positive gx is equals to limit x tends to n positive. What is gx? The function x minus greatest integral of x. Okay. Is equals to limit x tends to n positive. You can separate these terms, x minus limit x tends to n positive greatest integral of x. So this is n only minus, see, n positive. N positive means greater one. So greatest integral of x cannot be greater. You see here, what does x denote? At x implies greatest integer less than or equal to x. Greatest integer less than or equal to x. So n positive means bigger one. So you cannot take the bigger one. You can take the smaller one or the number itself. So this can be n only. It cannot be n minus 1 or it cannot be n plus 1. This can be n only. So n minus 1, n equal 0. Okay. Now it is observed that the left hand limit and right hand limit of the function g at x equal n does not coincide. Does not coincide. What is does not coincide? Means you are not getting same value. In the first one you have got 1, in the second one you have got 0. In left hand limit you have got 1, right hand limit you have got 0. So this does not coincide. Okay. So it is observed that the left hand limit and right hand limit of g at x equal to n does not coincide. Therefore, g is not continuous. G is not continuous at x equal n. Hence, g is discontinuous at all integral points. So this is finished. Okay. Next heading is composition functions. Okay. Theorem. What is the theorem? Suppose f and g are real valued functions, f u n c t i o n s, such that f o z is defined at c if g is continuous at c, and if f is continuous at g of c, then f o z is continuous at c. Okay. See. Suppose f and g are real valued functions such that f o z, what is o here? Multiplication. F o z is defined at c if g is continuous at c. What is c here? The point. Okay, at c, and if f is continuous at gc, then f o z is continuous at c. F is continuous at c. Suppose I am taking example. Okay, example 1, fx equal sine of x square. You see, this is a composition of two functions. Okay, the first one is sine x and the other one is x square. Okay, see here gx equal sine x and hx equal x square. Gx equal sine x and hx equal x square. So you can prove this. See, GOH of x. What is GOH of x? It is G of hx. Okay. I have taken the example as fx equal to sine of x square. This is a composition of two functions. One is sine x and the other one is x square. So here I have taken gx equal sine x and hx equal to x square. Now you can prove this. Is the value of you have taken gx equal sine x and hx equal x square is true or not? Okay. See what is the proof. How can you prove this? Now GOH of x can be written as g of hx is equals to g of, what is hx? You can see this is hx equal x square. So this is x square. Now you see gx equals sin x. Here this is g of x square. Compare these two. Replace this x by x square. What you will get? This x will also be replaced. Okay. So you will get sine of x square. And what is sine of x square? This is f of x. Means f of x equal GOH of x. Okay. F of x equal GOH of x. Similarly, if I take another example, number 2, example 2, fx equal modulus of 1 minus x plus modulus of x. Okay. 1 minus x plus modulus of x whole modulus. Okay. Here gx equal 1 minus x plus modulus of x and hx equal modulus of x. Okay, or you can say determinant of x. See, then HO g of x is equals to h of gx. Okay, h of what is gx? What is gx? You can see here gx equal 1 minus x plus modulus of x. So I will replace here 1 minus x plus modulus of x. Okay, is equals to, again you see what is hx? Hx equal to modulus of x. So replace x by this term. Okay, so this is modulus of 1 minus x plus modulus of x whole modulus, because h of x equal modulus of x. Okay, so replace this x by this one, hx equal to modulus of x. If I replace this x by this, so I will get here modulus and x is equals to this one. Okay, so is equals to f of x. So if I change this term, you will not get, suppose gx equal to sin x and hx equal to x square. If I write here HOG of x, HOG of x, see, if I write HOG of x, what I will get? Suppose I am writing HOG of x. So what I will get? H of gx is equals to h of, what is gx? Gx equal sin x. So h of sin x. And what is hx? X square. So replace x by sin x. So what you will get? Sin of x whole square. So this is sin x into sin x. So you are not getting fx, not equal to fx. So I cannot take HOG of x. In this case I will not get fx. So this is wrong. Okay. Similarly, in this case you cannot take FOG of x. You have to take h of gx. Okay.